Welcome back to my YouTube channel, and today we are going to be talking about the Laplace, proving the Laplace transform of cos kt is equals to s over s squared plus k squared. So now we're going to be using integration by parts as usual. So first of all, we put it into the Laplace main form. So we have it as the Laplace transform of cos kt, which is f of s, is equal to integral from infinity to 0. F of t is cos kt, and we have e raised power minus st dt. So what we do is using integration by parts, we pick our u and we take our dv. So we use u is equals to cos kt, and dv is equal to e raised power minus st dt. So we do du is equals to when we differentiate cos kt. Differentiation of cos kt is equals to minus k sin kt, that is equal to minus k sin kt. Then integration of dv to v will be equals to e raised power minus st over minus s. So since we have gotten our values, then we can move on into applying the formula. And we know that the formula for integration by parts is the integral of u dv, integral of u dv is equals to u v minus the integral of v du. That is the formula for integration by parts. So we just apply the formula. We have our Laplace transform of cos kt to be equal to our u times v, which is equals to cos kt times e raised power minus st over minus s. Now since it has bounds, so we just apply the bounds infinity and 0 to infinity and 0. Then infinity and 0, then minus the integral from infinity to 0 of v du, that is equal to minus k sin kt times e raised power minus st over minus s. So here we have minus up and down, the minus can cancel each other out. So we can continue from here. First of all, let's focus on cos kt times e raised power minus st. We know cos kt, when we put infinity, now we have minus here. So as I've been saying before in my former videos, we have something raised power minus, that means it's going to come down and the minus is gone. So we will have it as cos infinity over e raised power infinity times minus s. In if you apply infinity, and if you apply 0, you would have cos 0 over e raised power 0 times minus s. So if we finish this divided by infinity, this is going to be 0, and on this edge we are going to be having it as minus cos 0 is equals to 1, which is 1 over e raised power 0 is 1. 1 times minus s is minus s. So what we are going to be having here is minus cancel minus. We have it as 1 over s. That is what we are going to be getting as our answer. So now that we have known the value for cos kt when we apply our bounds, so that means this is equals to 1 over s, which is this, minus, now bring our k and n, since they are constant out, we have this as k over s, integral from infinity to 0 of sine kt times e raised power minus st. So now this is also another integration, and we do integration by parts again. So when we do integration by parts for this one, we pick our u is equals to sine kt, and we also have our dv equals to e raised power minus st dt. Let's not forget our dt value. E raised power minus st dt. So if we differentiate this, we have du is equals to k sine k the definition of sine is cos. So k cos kt dt, and the v to v we would have it as e raised to power minus st over minus s. So we just apply the formula into this one right here. We have this as this is equal to 1 over s minus k over s. This integral right here, let's put it into brackets. We have uv, that is sine kt times e raised to power minus st over minus s, over minus s. So we have that, yeah, we have that as over minus s. Then we apply the bounds infinity and 0, infinity and 0. Now minus from v du, that is integral from infinity to 0 of v du. Our we have this as k over minus s, k over minus s times cos kt e raised to power minus st dt, closing big bracket. So now, first of all, what is our sine kt e raised to power minus st? When we put infinity and 0 going to give us, if we look for it, when we put infinity here, we would have it as sine infinity over minus s times e raised to power infinity. Then we have minus sine 0 over minus s times e raised to power 0. So first of all, sine here we have sine infinity divided by e raised to power infinity. This is going to give us 0, and on this other end, sine 0 is equal to 0. So the entire thing is going to give us 0. That means the entire what is here is equal to 0. So that means that cancels out. So since this is equal to 0, that cancels out. Therefore, we have it as 1 over s minus k over s into brackets of, now we bring this constant out, we have minus k over minus s here, that means the minus is going to cancel each other. And we have the integral from infinity to 0 of cos kt e raised to power minus st dt. So we have this as cos kt e raised to power minus st dt. So now so if we move on, if we move on with this, if we move on with this, we are going to notice that if we continue integrating, we are just going to keep integrating. Sine will become cos. You see there, after the first integration, the cos became sine. Also, the sine became cos back again. So the way that we did our Laplace of sine t using integration by parts is the same way that we are going to be doing this using integration by parts, which is we are going to identify this as Laplace of cos kt, and we know what we are actually looking for is the Laplace of cos kt. So we just have to put it into like terms and find the solution to the formula. Then we get our answer for Laplace of cos kt. So let's do that. So now, if we move on, first of all, let's expand this. We have minus times minus, we cancel each other. So we have Laplace of cos kt, which is what we have started with, is equal to 1 over s minus k times k, we have that k squared over s squared. Then we have this. Now we are going to identify this as our Laplace of cos kt, because if we look at the first here, the integral from infinity to 0 cos kt raised to power minus st is the Laplace of cos kt, and this is it right here. So we just keep it there as our Laplace of cos kt. So what we just do, we collect our like terms. All the ones with Laplace of cos kt will come to one side, and the other constants go the other way. So we have Laplace of cos kt. This one comes in, becomes plus k squared over s squared. That is the Laplace of cos kt is equal to 1 over s. So as let's factorize Laplace of cos kt out. I have Laplace of cos kt into brackets. Now I open my big bracket 1 plus k square over s square, which will, if we simplify it, is going to become s square plus k square over s square here. So that will be that, which is equal to 1 over s. So what we just do is divide both sides by whatever is at the back of Laplace of cos kt. So we have Laplace of cos kt is equal to 1 over s divided by what is here, s square plus k square over s square. And we know how division works. Whenever we are dividing something, we will change it to multiplication sign and it will flip over. So that means if we change this to multiplication sign over here, if we change it to multiplication sign, then this becomes s square over s square plus k square, if you can see it. So here, s here will cancel one of the s here, and we are going to have Laplace of cos kt to be equals to s over s square plus k square. This is our final answer, and we see that it matches with what we have here. So that means our formula is correct. So we can go over it a little bit one more time. So now Laplace of cos kt, first of all, at the first glance of it, for somebody that, if you are somebody that is a little bit fairly good at integration by parts, integration as a whole, you will realize that first of all, looking at this, we know that it might not look possible with you. It might not look possible in your eye, because when you there is no factor there that can be differentiated up to the point zero. Like cos kt is a continuous function. If you cos, differentiate cos, will give you sine, differentiate sine, will give you cos, differentiate cos, will give you sine, will give you cos. It will continue like that without an end. And e raised to power minus st, e raised to power minus st cannot be disintegrated. If you differentiate e raised to power minus st, it is the power that is over there that you are going to differentiate. The e raised to power minus st would remain, and if you integrate it also, e raised to power minus st does not leave. So looking at it, it might seem impossible at first, but when we move on with this, you see, you first integrate it, get sine, and integrate it the second time, get cos. When you get your cos, you factorize, and that's how we got it. So thank you and subscribe.